Now, if your angle is between 90 degrees and 180 degrees, then the reference angle of this arranged angle is equal to 180 degrees minus the theta. So theta prime, the reference angle, is equal to 180 degrees minus theta, or say the pi minus theta. And if your angle greater than 180 degrees but less than the 270 degrees, then the reference angle theta prime is equal to theta minus 180 degrees, or say the theta minus pi. And if your angle is greater than 270 degrees but less than 360 degrees, then your reference angle theta prime is equal to 360 degrees minus theta. So in a word, the reference angle of a given non-quadrantal angle in the standard position is formed by the terminal side of this angle together either with the positive x-axis or with the negative x-axis. So in one word, this theta prime, this reference angle, must be a acute angle, which is between the 0 and the 90 degrees. So this is how we figure out the reference angle for a given angle. If your angle bigger than the 360 degrees, you may just throw out any multiple of the 360, and then you may first write this angle as the sum of the multiple of the 360 degrees plus another angle which is between the 0 and 360. And then from that step, you can find the reference angle of this arranged angle. And let's look at this 4 graphs again. So if your arranged angle is in the quadrant 1 or the quadrant 4, then the reference angle is formed by the terminal side and the positive x-axis. If your arranged angle is in the quadrant 2 or the quadrant 3, then the reference angle is formed by the terminal side and the negative x-axis. Okay, so formed by this terminal side and the negative x-axis. Now let's look at one example. Let's look at the page 444, problem 38. Sketch the given angle in standard position and find its reference angle in degrees and the radians. So we have the 390 degrees. Let's go back to the whiteboard. So page 444, problem 38, and the given angle is 390 degrees. So we may first write this as a multiple of the 360 degrees plus another angle. So this is equal to 360 degrees plus 30 degrees, right? Now we can sketch this angle. So 360 degrees, 1 revolution, right? And followed by another 30 degrees. Okay, 30 degrees is like this. So just write here. So this is the 30 degrees. Then you get 390 degrees. Now tell me, what is the reference angle of the theta? 30 degrees, right? It's formed by the terminal side of this angle and the positive x-axis. Okay, so it's the 30 degrees. In radians, pi over what? Pi over 6, right? So you have the, okay, 30 over 180, you get 1 over 6. So this is the first example. Now let's look at another example. And let's look at the 31. 5 pi over 3. Theta is equal to 5 pi over 3. So now this time, you may write this as the 2 pi minus the pi over 3. So let's draw the sketch. We know 2 pi, 1 revolution, right? And this is the pi over 3, or short of 2 pi. So let's first draw the negative pi over 3. So negative pi over 3 is like this. This guy, negative pi over 3. So 2 pi minus the pi over 3, that should be this angle. Right. So that is a 5 pi over 3. Then what is the reference angle? Pi over 3. Right. Pi over 3. Sorry, pi over 3. Then in degree measures, 60 degrees, right? So pi is equal to 180. 180 divided by 3, get the 60 degrees. Now let's look at the 34. Theta is equal to negative 210 degrees. And you can rewrite this as the negative 180 degrees minus 30 degrees. So first, you get negative 180, half revolution, right? And you get another 30 degrees. So it's here. And this is 30 degrees, right? So now this one is the negative 210 degrees, right? Then what is the reference angle? 30, right? So theta prime, the reference angle, is equal to 30 degrees. In radian measure, pi over 6, right? Pi over 6. And let's look at the 36. Theta is equal to negative 13 pi over 6. And you may rewrite this as the negative 2 pi minus pi over 6, right? So let's get the sketch. Negative 2 pi, just 1 revolution clockwise, right? So you have the 1 revolution clockwise, and followed by another angle of the pi over 6. So pi over 6 here. So finally, this is the negative 13 pi over 6. And what is the reference angle? pi over 6, right? You have the pi over 6.